So today we are looking at introduction to enzymology practicals, and basically we are going to look at the factors affecting enzyme activity. So we'll start by looking at some key terms as catalyst, enzyme active sites, and substrates. So what is a catalyst? So a catalyst is just a substance that speeds up a chemical reaction without it being changed. And an enzyme is a biological catalyst, which is usually protein in nature. And the active site is the part of the enzyme where the substrate binds to. And the substrate is the reactant molecule that the enzyme works on. So as you can see over here, so this is our enzyme with its active site, and this is the substrate. So the substrate binds to the enzyme at the active site to form an enzyme substrate complex. Now, let's look at enzyme substrate reaction. So what we have to note is that in an enzyme substrate reaction, substrates bind to the enzyme's active site to form an enzyme substrate complex. The enzyme slightly changes its shape as the substrate binds well to form an enzyme product complex. The enzyme then releases the products, making it free to bind to other substrate molecules. So as you can see from our illustration over here, so this is our enzyme with its active sites, and this is our substrate. So what happens is that our substrate binds to this enzyme at the active site to form an enzyme substrate complex. And as this happens, the enzyme changes shape slightly as the substrate binds to it to produce an enzyme product complex. And as this happens, the enzyme is able to release the products, leaving itself alone to allow other substrate molecules to bind to it. Now, let's start by looking at some of the factors affecting enzyme activity. So the first factor that we are going to look at is temperature. So what we have to note is that enzyme activity occurs within a narrow range of temperature compared to an ordinary chemical reaction. And also, each enzyme has a certain temperature at which it is more active. And this point, or this temperature, is called the optimum temperature. Now, so let us just study this graph showing us how temperature affects enzyme activity. So as you can see over here, as temperature increases from 0 to the optimum temperature, more kinetic energy is being produced. Hence, the rate of reaction also increases. Now, so at this optimum temperature, the rate of reaction becomes maximum. And as temperature increases from the optimum temperature, that is from 65 to 90 degrees Celsius over here, the enzyme denatures, and as a result, the rate of reaction decreases. So we are saying that enzyme activity gradually increases as the temperature increases towards the optimum temperature, as explained earlier. And at optimum temperature, which is at this point, enzyme activity or the rate of reaction is maximum. And also above the optimum temperature, so which is from 65 to 90, enzyme is denatured, and this results in a decrease in the enzyme activity as it reaches a maximum temperature at which the enzyme activity is lost. Now, so the next factor that we are going to look at is pH. Now, so what we have to note is that enzymes are basically protein substances that contains acidic carboxylic groups and basic amino groups. So the presence of these groups, so the acidic carboxylic groups and the amino groups makes enzymes to be affected by changes in pH values. And also each enzyme has a pH value at which it works best with maximum efficiency, and this is called the optimum pH. So looking at the graph over here, we have two types of enzymes over. So we have enzyme A over here, and we also have enzyme B over here, and this happens to be our enzyme activity or the rate of reaction, and this is the various pH. So what we can say over here is that with enzyme A, it has an optimum pH around 7.0, whilst enzyme B has an optimum pH around 11.0 from the graph. Now, so the third factor that we are going to look at is enzyme concentration. Now, so what you have to note is that increasing the enzyme concentration will speed up the reaction, and also once all the available substrate has bound to the enzyme, the reaction will no longer speed up. This is because there will be nothing for the additional enzyme to bind to. And what we also have to notice that we have three main conditions related to enzyme concentration in an enzymatic reaction. And these conditions are at low enzyme concentration, the second at intermediate enzyme concentration, and the third at high enzyme concentration. So we will just pick them one by one and study what happens in each of the conditions. So let's start by looking at low enzyme concentration. So what happens is that at low enzyme concentration, there are few enzyme molecules and excess substrate molecules. So these are the excess substrate molecules over here with few enzyme molecules are seen. And also as there are too few enzyme molecules to allow all the substrate molecules to find an active site at one time, the rate of reaction is therefore half the maximum rate of reaction. So as we can see from the graph over here, so we can see that at this point, we have a maximum rate of reaction. So at low enzyme concentration, the rate of reaction is always half the maximum reaction as shown on the graph over here. So the next condition is has to do with intermediate enzyme concentration. So at intermediate enzyme concentration, what we have to note is that we have equal enzyme molecules and substrate molecules. And as this happens, all the active sites of the enzymes will be filled with the substrate molecules at one time to double the rate of reaction to its maximum. So as you can see from this graph, so we can see that the rate of reaction has doubled from here to its maximum rate of reaction as seen in this graph. So the last condition has to do with at high enzyme condition. So let's see what also happens over there. So at high enzyme conditions, so the addition of further enzymes molecules result in excess enzyme molecules as seen over here. So these are the excess enzyme molecules with empty active sites. Now, so these enzyme molecules will have no effect as there are already enough active sites to accommodate all the available substrate molecules. Therefore, there will be no increase in the rate of reaction. So as we can see over here, we still have excess enzymes with their active sites not being filled over here. So what happens is that in this case, though, like the rate of reaction will not increase. So the nature of graph will look like this as seen over here. So the next and the last factor that we are going to look at is substrate concentration. So what we have to note is that in the presence of a given amount of enzyme, the rate of enzyme catalyzed reaction increases as the substrate concentration increases. And when a limiting rate is reached, further increase in the substrate concentration produces no significant change in the rate reaction or in the rate of reaction. Now, also, we also have three main conditions related to substrate concentration in an enzymatic reaction. And these are the low substrate concentration, the intermediate substrate concentration, and the high substrate concentration. So let's take them one by one and look at what happens at each stage. So at low substrate concentration, we have excess enzyme molecules in solution with limited substrate molecules. So as you can see over here, so we have excess enzyme molecules in solution with limited enzymes, with limited substrate molecules over here. And this condition results in some of the enzyme's active sites not being filled, since there are too few substrate molecules to occupy all the active sites of the enzyme. Hence, the rate of reaction is half the maximum reaction in this condition. So as you can see from the graph over here, so this is the maximum rate of reaction. So at low substrate concentration, the rate of reaction is half the maximum rate of reaction. So the next is the intermediate substrate concentration. So so what happens here is that we have almost equal substrate molecules and enzyme substrate molecule. And as this happens, all the active sites of the enzymes will be filled with the substrate molecules at one time to double the rate of reaction to its maximum. So as you can see over here, so we have equal moles or amounts of the substrate molecules and the enzyme molecules, and all the active sites of the enzyme molecules are being filled with our substrate to yield a product. So what happens is that the nature of graph will be seen as this. So where the rate of reaction will be maximum over here. Now, so the last condition that we have to look at is at high substrate concentration. So at high substrate concentration, the addition of further substrate molecules result in excess substrate molecules, and the excess substrate molecules are unable to find any free active sites of the enzyme to bind to. Therefore, there will be no increase in the rate of reaction, and the nature of graph is represented as this. Thank you.